Hi, I am MAGAWAY and today we are going to talk about the atomic structure. In this lesson, we are going to talk about what is atom, history of atom, atom subatomic particles, isotopes, atomic number, mass number, and calculating the average atomic mass. What is atom? Atoms are the basic building blocks of a matter, and atoms are the smallest unit of any chemical elements. Like a bar of chocolate, which is composed of a variety of different ingredients, matter is composed of a variety of atoms. Let us now tackle the history of atom. Democritus. Democritus is an ancient Greek philosopher who first developed an atomic theory. In his atomic theory, he believed that matter is made up of tiny, hard, and small invisible particles surrounded by empty space, and these particles are called atomos, Greek word meaning not to be cut. Next is John Dalton. John Dalton is a British chemist, physicist, and meteorologist in the early 19th century. He proposed the Dalton's atomic theory in 1803, and in his atomic theory, he stated that all matter is made up of tiny particles called atoms. He also stated that atoms of each element are same in size, mass, and other properties, but they are distinct from atoms of other elements. Atoms cannot be subdivided, created, or destroyed. He introduced the solid sphere model in 1803. He believed that atoms are tiny balls formed in same material that cannot be broken. J.J. Thomson. J.J. Thomson is a British physicist, and he discovered the electron during the cathode ray tube experiment in the 19th century. He introduced that atoms consist of tiny negatively charged subatomic particles called electrons that are embedded in a large and positively charged sphere. J.J. Thomson proposed the plum pudding model in 1904. He believed that negatively charged electrons are like plums, surrounded by a positively charged pudding. Next is Ernest Rutherford. Ernest Rutherford is a New Zealand physicist and also known as the father of nuclear physics. He introduced the nuclear model of an atom, and he discovered the small, dense, and positively charged nucleus. He also stated that electrons surrounds and moves around the nucleus like a planet. Niels Bohr. Niels Bohr is a Danish physicist that is known for his pioneering work in atomic structure. He introduced the planetary model in 1913, and he believed that negatively charged electrons orbit the nucleus in orbits that have set and size. Last is Erwin Schrödinger. Erwin Schrödinger is an Austrian physicist, and he proposed a quantum model in the 1920s. Schrödinger's model builds upon the ideas of wave-particle duality, which suggests that particles like electrons can exhibit both wave-like and particle-like behavior. He introduced the Schrödinger's equation, which defines the quantum mechanical system wave function, and it provides probabilistic information on a particle's location and other observable properties such as its momentum. Let us now talk about the three subatomic particles of atom. These subatomic particles are the proton, neutron, and electron. Electron orbits the nucleus, which is located at the center of an atom, and nucleus contains protons and neutrons. Proton have positive charge, neutron has no charge, and the electron have negative charge. Atomic and mass number. Atomic number represents the amount of protons present in the nucleus of an atom. It is located at the upper left of the element and in the middle it is the letter symbol for the element. On the other hand, mass number represents the number of protons and neutrons present in an atom. An isotope is one of two or more species of an atoms of a chemical element that have the same atomic number and location in the periodic table as well as a virtually similar chemical activity but differ in atomic weights and physical characteristics. Every chemical element has one or more isotopes. Let us now move on in computing the average atomic mass of an element. To compute the average atomic mass of an element, we must first need to gather the isotope information. This information includes the isotopic symbol, the percent abundance of each isotope, and the atomic mass of each isotope. Next is convert the percent abundance to decimal. Convert the percent abundances of each isotope to decimal fractions by dividing by 100, or moving decimal places. After converting the percent abundance to decimal, let us now move on multiplying atomic mass by percent abundance. Multiply atomic mass of each isotope by its percent abundance. This gives you the contribution of each isotope to the average atomic mass. After that, sum up all the contribution, and that gives you the average atomic mass of an element.